So welcome back. So this is Madhav again. So today we are just going to discuss about circular queue. So today we are just going to discuss about circular queue. So firstly, we need to just know the reason for just. So we need to just know the reason for inventing a circular queue instead of using the normal queue. So let me just open Paint. So basically, if you just see here, in queue, basically we will just add the values like this from here to there. So 3, 4, 5, and then so on. So basically, we have a logic like if these both, if these both are present, then we will just pass a command like the queue is full. So basically, if these elements are not there in middle, then we can't say the queue is full, right? It's impossible. So based on those both elements, we can't just define like queue is full. So to overcome this drawback, we are just inventing a new method which is known as circular queue. So circular queue is basically circular shape in circle shape, well known by everyone maybe. So it's in circular shape. Yes, draw another one and yeah. So here if we just see, we'll just divide it into places. It will just gets divided into different places. So here this is zeroth position and 1, 2, 3, 4, 5. So here the size is 5. So basically in a normal queue 0 and 5 won't attach, right? As I had said before, only the first and last element will just depend to give a printf statement like queue is full. So to overcome the drawback, we are just using this circular queue so that we may just use this both as a connection. So the main use of a circular queue is to just use this connection. So in this circular queue, if we need to just define whether it is full or not. So first let's discuss about if we need to just pass a command like queue is full. So if we need to just say queue is full, then we need to just uh, write the thing like if we are having an element in this first and we are having an element till this last. So in this we can just say that the queue is full. So this is a very basic condition to just say the queue is full. So till friend until max minus 1. So we need to just consider the value of friend, not the first position. So I was just confusing you guys, right? So not the first position. The first position is not important. It is friend. So the value of the friend. So this is the main thing. So the friend is the main thing. The friend. So the value of the friend is very important, and max minus one. That is nothing but this size minus one. So the size minus 1 is known as max minus 1. As in the given figure, the size is 6. So the 6 minus 1 is 5. So as if we start from 0, 0, 1, 2, 3, 4, 5. So it's occupying 6 positions, right? So we need to just consider the value of the friend, and we can just say that queue is full if we are having elements from the first position to the last position. So if we need to just know the number of vacancies, so we need to just use it from friend. So from friend to max minus 1, and the number of vacancies can be known very easily. So that's not our point. I was just telling how to just check. So and the another basic condition for to know whether the queue is empty or not is just the friend and rare value if the both are in its initial position. That means here the initial position will come under 0. So 0 is not the initial position. So my wording is wrong. We need to just say like if both front and rear has not even started, that means they are still in -1. So if this is possible, then we can just say that Q is empty. So -1. We need to just increment the values, right? So to we can just say that -1 if the front and rear are both in -1 positions, then we can say that Q is empty. So these both are very basic conditions. Right? Let me just show you a pic. So this is taken from internet. So here we can just see here the front is 3, rear is 4. So from here we can just say that here this is front and this is rear. So here if we just represent in this circular queue, this will be like this. Said before 0, 1, 2, 3, 4. Here the maximum size is 5, so it will just come from 0 to 4. So this is the representation of a circular queue if it is given like this. So this is a basic thing. So you just check here operations on a circular queue. So operations is nothing but the performance, or we can just say that the elements which we use in this whole process is also known as operations of a circular queue. So we need the help of front, and we also need the help of rear, and we also do the process NQ, and we also do the process DQ. NQ is nothing but the insertion of a value into rear. So in as I had said in the before classes, in during the process of insertion, we need to just use the rear thing, and during the process of deletion, we need to just use this front. So this is all about circular queue operations. So if we just go in depth into NQ operation, the steps of NQ operation are: first we will check whether the queue is full or not. So as I said before, to check whether the queue is full or not. So we just write a program through this algorithm. I think this is fine. Let me just use my compiler Turbo C++ Windows 7. Already I just practiced this, so let me just write something new. And so let me just include these things so that we can just use whatever required. Hash include ponyo.h, hash define size 5. So here we can just see we need to just declare array size. So int arr. So I am just declaring the size is just declared globally, right? So we need to just put the array value as globally. So we need to just declare these things, basic things. Yeah. So front equal to -1, rear equal to -1. So void insert, that is NQ. So for our remembering, I was just using this insert. So let me just declare an item. So I will just say about this item. Item, it is an integer type variable. So this is used to just enter an element to insert into a circular queue. So this int item uses like this. So to just enter the element into a queue, we use this int item. So as I said before, we need to just check whether the queue is full or not. So here it is not mentioned properly. So we need to just check it is empty or not. So let me just check if front double equal to -1 and rear double equal to -1. So if this is possible, then we can just put a thing like, so we can just say like front front equal to rear equal to 0. So you can just say that we had a chance, right? So if front double equal to -1 and rear double equal to -1, so we can just declare here, right, front equal to rear equal to 0. So it is just giving its initial position in a circular queue. So we need to just declare like this for entering an element into this queue. So let me just write a printf statement. Enter the element into queue. Let me just write a slash in new line statement so that won't get more complex. Yeah, so let me just write the scanf percentage t comma, as I just declare an integer variable which is known as item. So I was just writing the scanf statement here as item. So we need to just as I said before, during the process of insertion, we need to just check the rare thing. So during the process of insertion, we need to just check the rare. So we need to just put the value into the rare. So as I declared as array of size, ARR is the name. So I was just using this ARR of rare is equal to item. So the thing or the name which is at the right side will just provide the value to the left side. So this is a basic C knowledge. So let me just pass a command like uh, item as inserted. So here I was just passing a command like item has been inserted. So till here if is completed successfully. So let me just talk about else if. So as we had seen in this, so let me just save this. So let me just say like this. So if we see here first, we need to check whether the queue is full or not. So if we need to check whether the queue is full or not, here we are just check. Here we didn't check anything. So we are just using the thing to enter the element from its initial position. So we need to just check whether the queue is full or not. So if we need to check whether the queue is full or not, we have a very basic thing like if rent uh, if rent double equal to 0 and rare double equal to size minus 1. As I said before, this is a very basic condition to check whether the queue is full or not. So without confusion, we will just learn about this in the upcoming thing. So rare plus 1, yeah, we will just discuss this in the upcoming one. Rare plus 1 percentage size is equal to uh, uh, double equal to rent. So this is also a very basic thing which we can just use. So here if we just see rare plus 1, okay, so let me just save until here. So we will just get into this picture. So here the value of rare is 4. Rare plus 1 percentage sum. That means 4 plus 1 it's 5. So 5 percentage 5, that means the remainder is uh, 5 ones 0, no. So okay, it's getting into its initial position. So if it is equal to friend, that means if rare plus one, so the rare position is important in the process of insertion, right? So if rare plus one, that means its next position is equal to its friend, then we can just say that the queue is full, right? So here we can just see the rare position is 4. If rare plus 1 percentage 5, so 5 percentage 5, so its next position is 0. So here we can just say that the friend value is in 3. So we can just say if it is double equal to friend, then we can just say that queue is full. So here it is not full because the friend is in its third position. If it is in 0, sorry, if the queue is full, then it will just automatically get its another case. So let's divert and get into the thing. Sorry. Okay. So this is use it like this. So I was just passing a statement like printf q is full. I was just passing like q is full. So till here I think everything is fine, right? So here we need to just write another else statement, that is here we need to just write this else because if our position is in last, so our size is 5. If its position is in 5, then it should not get incremented to 6. So it will it's needed we to get that into its initial position, right? So for that thing we are just writing this if so rare is equal to rare plus 1. As I said before, modular division in the above thing, right? So in the case of Q is full, I just explained about this. So let me just write the size. So I was just passing a command like enter the element. So let me just pass a new line command. Sorry. Yeah. So let me just write this scanf. So the if is one condition and else if is another condition. So this is a else. So this else is also another condition. So what condition it may be? The element just gets enters into the item. So the item just gets enters into the rare, right? So everything is same. So let me just write this percentage t and item. So ARR of rare is equal to item. So let me just pass a command like element inserted. Okay, so everything is fine until here. So this is insertion and let's get into the deletion. Sorry, I just forgot about this uh, algorithm. We were just not following the algorithm. I was just following thing. Sorry. Let me just get into this. We need to just set the value as -1 when we just insert the first element in the queue. Front and rare both are set to 0. So these steps are given, right? So rare is equal to rare plus 1. So in every case, this may not work properly. So I have just used that thing so that we should not get any errors, right? So let's get into this DQ. So DQ operation is just deletion of the elements, right? So the deletion of the elements is done with the help of a DQ. So first we need to check whether the queue is empty or not. If queue is empty, we can't perform a DQ operation. because if the queue is not consisting of any elements, there is nothing to delete, right? So this is a basic thing. Let me just try this tq, uh, void delete del, as we had a delete function command. So let me just initialize it as del. uh, so firstly we need to check whether it is empty or not. If friend double equal to -1, so this is a basic condition. Rare double equal to -1, so we can just say q is empty. So q is empty, we can just say that q is empty, right? So let me just write here a new line, I just forgot it. Here also we need to just write a new line, q is empty. So here the first if is just completed. So here we have another possibility. So we need to check if front and rear both are equal. Then we can just come to a conclusion like we had only one element in this queue. So if front and rear both are equal, so we can just say like we had only one element in this queue. So we can just come to a conclusion like that. So let me just write the else if friend double equal to rear. So let me just write this printf statement. Deleted element is percentage t comma arr of friend. As I had said before, in the case of deletion, we need to just use this friend thing. So after that, we need to just initialize the value of friend to -1 and rear to -1, because we don't have any use with this after the element gets deleted. So we need to just initialize its value from for to its starting position. So after this else if, we need to just write the normal else, that is deletion of elements. So let me just write the deletion of elements. So deleted element is percentage t comma arr friend. So friend is equal to friend plus 1. So let me just keep it in. This is a modular division, as I was saying from the starting. So this says nothing but increment, but the additional case is just if it is in its last position, then it will just reach to its initial thing. So I was just saying it from starting, right? So this is deletion. So let me just write another one for display. Display is nothing but the displaying of elements after insertion or after deletion. It depends upon the switch case. So we need to just discuss about the display. So we need to check whether the queue is empty or not. So the basic condition to check whether the queue is empty or not is if friend double equal to -1 and rear double equal to -1. Then we need to just pass a command like queue is empty. So let me just allow me to just write a new line command here. Sorry, yeah. Here also. So I had just written that the queue is empty or not. Queue is empty. Sorry. So there says elements in the queue. So elements in the queue, I was just so here I need to display so I need to just initialize a variable of integer type, which is I. So I will just use this in else. Uh, so let me just pass a command like elements in the QR. So let me just use this slash in. So let me just write a while loop so that it will not just terminate until the condition gets satisfied. So let me just write a while loop. I had just written a while loop. So let me just print the elements. So printf percentage d comma. So I need to just initialize the I as print. I just forgotten that. ARR of I. So again, I am doing this modular division. I is equal to I plus 1 percentage size. Percentage size. So let me just write the last one, that is void main. That is nothing but this switch case. So I was just passing this command to just show the um, to show them what are the options they have. So let me just insertion slash, and so this is for new line, deletion. So this is new line, and the last one display. I think this is fine. Let me just close this. I need to just uh, declare a variable to just select my option. So let me just declare int opt. Let me just pass a printf statement. Enter your choice. So I was just placing this whole thing in a while loop. Let me just allow me to place this whole thing in the while loop. So I was just passing a command like to enter the choice needed. So let me just write a scanf statement, percentage t comma and opt switch opt. So I was just writing a switch case for this opt. Case 1 insert. So I was just writing this break. And I was writing the case 2, that is delete, and I was writing this break. Case 3, that is display, and I was just writing this break. I just forgotten to write another option, that is display. Sorry, exit. I just forgotten to write this exit. Yeah. Case 4, uh, exit 1, and I need to just write this default statement, right? I was just passing a printf command like wrong option. So I was just passing this wrong option thing. Uh, so basically here we need to just declare a thing like CLR SCR so that it will not save any previous output. Let me just save this code. I think everything is fine. Yeah. Okay then. As I was just saving this code and I was just comparing. So I just forgotten to just write this semicolon. Yeah, everything is fine. So I was not getting any errors right now. Let me just run this code. So it is just asking to enter my choice. So I was just inserting an element 8, another one 5, another one 3. So 853, let me just display. Yeah, so I was just getting this elements. So let me just delete, another one delete, another one delete. So let me just display at last. Queue is empty. So with this, we can just use this code for writing a circular queue. So I was just entering the option 4 to get exit. So this is about circular queue, basic circular queue. Yeah, thank you for listening.